Dear students of India and abroad, this is a video in which I will discuss about a problem of Asian Physics Olympiad which was organized by the Taipei, Taiwan in 2021. And this problem depends upon the water hammer effect. Water hammer effect. And before starting the video, this is a introduction about the water hammer effect. And the introduction is this problem studies variation of fluid pressure caused by pressure waves in a flow pipe. Proposed tasks mainly deal with the water hammer effect arising from both fast and slow closings of a flow control valve in the pipe. We consider only non-viscous liquids and liquid flow which are essentially one-dimensional. All pipes, including their walls, are assumed to be rigid, but liquids are not always considered to be incompressible. If a liquid element of a volume V naught at equilibrium under pressure P naught is subjected to a change of pressure delta P, the change of its volume delta V is assumed to be proportional to delta P, so that delta P is equal to minus B delta V V naught. So that delta P equal to minus B delta V upon V naught, where B represents the bulk modulus. For water, take rho naught means density, that should be 1 into 10 to the power 3 kilogram per meter cube, adds its equilibrium density, and B is 2.2 G Pascal. So this is part A, that is axis pressure and propagation of pressure wave, and marks of this part is 2.2. If we solve this part, then we will get 2.2 marks out of 10. And this part is in a uniform cylindrical pipe of length L. Water is flowing steadily along the plus x direction with horizontal velocity V naught, density rho naught, and pressure P naught. As shown in figure 1, the pipe is connected to a reservoir at a depth h and opens into the atmosphere at pressure Pa. Suppose the flow control valve T at the end of the pipe is then shut instantly, so that the oncoming liquid element next to the valve suffers both a pressure change delta Ps, that should be P1 minus P naught, and a velocity change delta V, that should be V1 minus V naught, with V1 is less than equal to 0. This causes a longitudinal wave of axis pressure delta Ps to travel upstream in the minus x direction with a speed of propagation c. Now we will see the diagram. This is the diagram, and this part represents the reservoir, and Pa represents the atmospheric pressure. Rho naught, P naught, and V naught are the density, pressure, and velocity of the liquid in initial stage, in the stage when the liquid is going towards the T point. This is T point, that represents a gate which is suddenly, instantly will be closed, and this is the length of this pipe is L. So and liquid is flowing in this direction. So this is the diagram, and part A is divided into two parts, and marks point of A1 part is 1.6, and the question is the axis pressure delta Ps is related to the velocity change delta V by delta Ps is equal to alpha rho naught c delta v. The speed of propagation c is given by c is equal to beta plus under root gamma upon rho. Find alpha, beta and gamma. This is A1 part, first question of part A, and marks of this part is 1.6 point. Now we will discuss the solution of. So we know that when the wall is closed suddenly, this wall if closed suddenly, then the waves, fluid waves reflected in this direction, and fluid is incident in this direction. So there is a surface, suppose this is a surface at which the waves, incident fluid waves and reflected fluid waves are collide to each other, and before this surface density is rho naught, pressure is P naught, velocity of the wave is V naught, and suddenly the density becomes rho 1, pressure becomes P1 and velocity becomes V1. So this shaded region represents the pressure wave with velocity c. So we know that in question it is given in problem that delta Ps, change in axis pressure, that should be equal to P1 minus P naught, or we can write P1 is equal to P naught plus delta Ps. So change in velocity delta V, it should be V1 minus V naught. V1 is velocity of reflected wave, fluid wave, and V naught is the incident fluid wave. So if we see that velocity of fluid in the pressure wave, that should be C plus V1, that is the velocity of fluid in the pressure wave. Similarly, we can show that the incoming fluid in the steady flow ahead of the wave, it should be C plus V naught. Ahead of the wave, it should be C plus V naught. So if we write the equation of continuity, it should be rho naught and velocity C plus V1, and in this direction it should be C plus V naught, rho 1 and velocity C plus V1. This is equation of continuity. We can consider it equation number 1. And we know that delta V is equal to V1 minus V naught, and delta rho, it should be rho 1 minus rho naught. So if we solve it, delta rho equal to, if we take rho 1 common, then it becomes 1 minus rho naught upon rho 1. And question 1, we know that rho naught upon rho 1, it should be C plus V1 upon C plus V naught. And we can put the value of rho naught upon rho 1 in this term. So it becomes rho 1 minus rho naught upon rho 1 C plus V1 of C plus V naught, and it becomes delta rho equal to, if we take rho 1 common, then it becomes 1 minus rho naught upon rho 1. Now we can put the value of rho naught upon rho 1 from this equation. So it becomes delta rho equal to rho 1 minus C plus V1 upon C plus V naught, and rho 1 C plus V naught minus C minus V1 upon C plus V naught, and it becomes delta rho upon rho 1 equal to C cancel out, V naught minus V1 upon C plus V1, or V naught minus V1 may be written minus delta V upon C plus V naught. So impulse imparted to the fluid must equal to the momentum change. Thus, in a short time interval tau, if you consider short time interval tau, and valve is closed, then we must have rho naught velocity in this direction. It becomes C plus V naught time short time, and change in velocity C plus V1 minus C plus V naught, and it should be minus tau delta P, and it may be written delta P minus delta P is P naught minus P1 tau, and delta PS, which we have already discussed, delta PS is equal to minus rho naught C. This is 1 plus, if we take C common from this term, then it becomes C is from outside 1 plus V naught upon C. This C plus V naught becomes 1 plus V naught upon C. We have taken C in outside, and it becomes V1, C cancel out, this C cancel out, V1 minus V naught, and that should be equal to minus rho naught C 1 plus V naught upon C delta V, and we can write delta PS is equal to minus rho naught C, and if C is very greater than V naught, then this term V naught upon C is ignorable, delta V. So this is PS equal to minus rho naught C delta V, and negative sign, this negative sign represents the direction of propagation is opposite to the positive direction for x-axis or and velocity. Otherwise the sign should be positive, or not also that for a compressional wave. When delta PS is greater than 0, the velocity imparted to the fluid particle is in the direction of propagation. While for an extensional wave, when delta PS is less than 0, the velocity imparted is in opposite direction of the propagation. From equation 4, it is given that delta P is equal to minus rho naught C 1 plus V naught upon C delta V. We can put the value of delta V from this equation. So it becomes delta PS equal to minus rho naught C 1 plus V naught upon C, and delta V becomes delta rho upon rho 1 into C plus V naught. And if we take C common from this bracket, then it becomes delta PS equal to minus, and this is also minus, so minus minus becomes plus. It should be in minus. So minus minus plus, and rho naught C 1 plus V naught upon C and delta rho upon rho 1, this C plus V naught, from this C plus V naught, if we take C common, then it becomes 1 plus V naught upon C. Now it becomes rho naught C into C becomes C square and 1 plus V naught upon C whole square delta rho upon rho 1. This is delta PS, and we can consider it equation number 6. Now from the definition of bulk modulus, we know that delta PS is equal to B V naught minus V1 upon V naught, where B represents the bulk modulus. And we can write B, V naught means 1 upon rho naught minus V1 means 1 upon rho 1 upon V naught is 1 upon rho naught. And after solving it, it becomes B rho 1 minus rho naught upon rho 1. Rho naught cancel out, and delta PS becomes delta rho upon rho 1. It may be equation number 7. Equation number 7. So from equation 6 and 7, we obtain this is delta PS, this is delta PS, this is delta PS. So rho naught C square from this side, rho naught C square 1 plus V naught upon C whole square delta rho upon rho 1, it should be equal to B delta rho upon rho naught. Here should be B. And delta rho upon rho naught cancel out. So it becomes rho naught C square 1 plus V naught upon C whole square equal to B. And we can also write 1 plus V naught upon C whole square equal to B upon rho naught, or we can write C 1 plus V naught upon C equal to under root B upon rho naught, or C plus V naught equal to under root B upon rho naught, and C equal to under root B upon rho naught minus V naught. And as per the definition of bulk modulus, if we take V naught upon C very less than 1, then we can ignore this term, and now C becomes under root B upon rho naught. So this is C in terms of bulk modulus. Now we will solve the A2 part, and A2 part is calculates values of C and delta rho S for the case of water flow with V0 is 4 meter per second and V1 is given 0. And we know that from equation 5 and 10 that C is under root B upon rho naught and delta PS is rho naught C delta V and rho naught C delta V is V naught minus V1 and here V1 is given 0. So we can write this is rho naught C V naught. So if we put the value then we know that V naught is given 4 meter per second. 4 meter per second. So C becomes under root B upon rho naught. B, putting the value of B and rho naught, it becomes 1.5 into 10 to the power 3 meter per second. This is the value of C. And if we calculate the value of delta PS, then it becomes V naught. This is V naught, and we can write V naught C rho naught, and it can be V naught rho naught. Value of C is under root B upon rho naught, and it becomes V naught under root B rho naught. V naught under root B rho naught. And after putting the value of V naught, B and rho naught, it becomes 5.9 megapascal. So delta PS is 5.9 times 559 times the standard pressure. So dear students, in this video I have solved the problem 2021 which has asked in the Asian Physics Olympiad examination held in Taiwan, and in this video I have solved A1 part and A2 part. In next video we will solve the next part of this paper. Thank you.